Hello, welcome to the second session on normal distribution. Let me share my screen. All right. So I have a question just to get started on the chat. If you were here in the previous session, you know that I put these over here just to answer things in the chat. So the first one, start off easy. How confident are you feeling with this topic on a scale of 1 to 5, where 5 is high? So you can just answer a number in the chat. So if everyone could do that, that would be great. And that also gives me an idea of how to pace the session and what to focus on. If you were not here in the first session, my name is Ashley from Miss IB Maths, collaborating with Exam Dojo. That's me. I am an IB teacher, tutor, and IB examiner. And in this session, we're going to go through a few definitions, formulas, key things that we need to know about normal distribution, just a little refresher. Then do some worked examples, and then do some exam questions and look at mark scheme, which is very important. So if you haven't already, grab a pen, paper, your calculator. You can take notes as we go along and answer questions as well, if you have that. And yeah, if you see this box over here on the screen, please answer. So do we have anything? All right, thank you for your comment. Anyone else want to share their number, how they're feeling? No wrong answers here yet. That would be really helpful for me. All right, I think we can make a start. So a little warm-up question to get our maths brains working. Give as many examples of continuous variables as you can. Put your answers in the chat. So continuous variables versus discrete variables. In our first session, we were looking at binomial distribution. So discrete variables, values that take very specific values. So continuous variables, what were those? A hint is that continuous variables have units of measurement attached to them. So if you can say 5 somethings, then that's a pretty good hint that it's a continuous variable. For example, 5 kilometers per hour or 5 centimeters. Very nice. Height, indeed. Skin color would not be a continuous variable. That is more of a category. So we call that qualitative data when you have categories. So things like colors. But yeah, weight, exactly, height. I'm looking this way because I have the chat on my iPad screen. And age, very good. These are all things that have units of measurement. So I'm 6 years old or 12 years old. They all have units of measurement. Very nice. And just to think about, those continuous variables can take all range of values, and that's going to be very important for normal distribution. Unlike binomial distribution, where we had, where's my pen? So when we had our discrete data, we were looking at very specific values of 0, 1, 2, 3, 4. And we knew they would always take whole numbers. Those were our variables of x. Whereas continuous data, and this is going to be the big difference between continuous variables and discrete variables, is any range of values between minus infinity, even negative, and positive infinity. So 0.22225, 5.167. That number is stuck in my head all the time. So here we have the sizes of leaves, which are actually normally distributed. Okay, so just to start with the formula booklet, it's always good to know what we have. Make sure you have the formula booklet open and next to you on the topic that you're on, so that you don't have to think about it, search for it, and it kind of gives you a hint when you look at the topic of what we're working with, what kind of questions they might be asking. Which formulas do you need to memorize for this topic? So which are not given that you need to make sure you've memorized before you go into the exam? Any ideas? Or not even necessarily formulas, but anything that you need to memorize to do with this topic of normal distribution. To answer the question of how long each session is, it's about an hour. So I try to keep it an hour because I know it's a lot to sit and listen to. If there's questions, then it can take a little bit longer, but about an hour. All right, so one of the things that they do not give us in the formula booklet is the empirical percentages. So empirical percentages are those 3 different percentages that we need to know for how the data is spread. And if you've not heard of that before or don't remember it, we're going to go through it, so don't worry. But we do have the standardized normal variable. That's the one that's given. And other than that, there isn't actually anything you really need to know or memorize. So that's quite nice. All right, so start with a continuous random variable is a variable that can take any value within a range of infinitely many values. Continuous random variables usually measure something. So like we were saying, if there's a unit of measurement attached to it, so height in, let's say, centimeters, weight in kgs, time in seconds, for example, temperature in degrees Celsius, or distance in kilometers. You know it's continuous variable if you can attach a unit of measurement to it. That's probably the easiest way that you can decipher between continuous and discrete, which is a question that they often ask. Is this a discrete or continuous variable? And it's easiest to just think, does it have a unit of measurement? If yes, continuous. If not, it's discrete. All right, you may be familiar with this diagram. This is known as the normal curve. So our normal distributions all follow the normal curve. So do most things in life. Like people's heights, for example. When you're a baby, you start with a very small height, you're quite short, and as you get older, you get taller, and then you get shorter again, actually, as you get older. Or you can think about most people between the ages of, say, 20 and 50 follow a normal distribution. You have a few shorter people, a few taller people, and then in the middle, most people are around the same height. You have very, very tall people, apparently in the Netherlands, and very short people in some places as well. But mostly people are around the average. So in the middle of every bell curve, let me change that color. In the middle, we always have our mean, the average. That's where everyone kind of lies. Test scores as well. Few people score low, few people score high, but most people are scoring the average. And we talk about the probability of X being within a certain range. So the probability of someone being between these values here, it's a range of values between this one and this one. So we're not finding things at a point. So remember, in discrete probability and binomial distribution, we had the probability that X could be 2, for example. That isn't something that we have, because if I have just a value like that, it's just a straight line. There's no probability under the curve there. So all of those, if you take it at a specific point, would actually be 0. There's no area under that of a straight line. So they're not going to ask you for exact values. They're going to ask you for a range. So it'll be more like the probability that X is more than 5, for example. So not at a single point. All right. Now, the area under the graph is totaling 1. Okay, remember all probabilities add up to 1. So this whole area under this curve, the whole area is equal to 1. All right, and we're going to be finding different probabilities. So the area here at this point, remember that was the mean in the middle halfway. So the probability under this part is 0.5, probability here is 0.5. Both of those adding up to 1. All right. Notation. We say X, our variable that we're looking at, so age or height or distance, is distributed, the squiggly line, distributed normally, N for normal. And then these are our parameters. Parameters are the things that change per question. So we have this weird Greek letter here, that's mu, you pronounce mu. And that is the average, the mean. Remember that point in the middle, average, mean. This one over here is sigma. My students love it when I say that. They actually don't. I think it's very lame because I make lots of sigma jokes. But that is sigma, lowercase sigma, the Greek letter. And that means standard deviation. So how far the data is spread from this mean. So these two are very closely linked. Standard deviation. All right. So we have standard deviation, and then we have the standard deviation squared, which is sigma squared. So that is when you take the standard deviation and you square it, you get the variance, or if you square root the variance, you get the standard deviation. So some questions. If the standard deviation is 5, what would the variance be? So you can type A and then the answer for the variance, and B and the answer for the standard deviation. So this is the other way around. If the variance is 144, what is the standard deviation? Giving you some nice numbers here with no decimals. Yeah, we have some quick answers over here. Very nice. So if the standard deviation is 5, the variance is just 5 squared, so 25. And if the variance is 144, standard deviation is 12, because 12 squared is 144. For most of the questions, we're not actually going to be doing much with variance. That comes into the exam questions not many times, but standard deviation, a lot. And I know these words may scare you. It seems like there's a lot going on. I mean, all of this looks Greek. It is. But it's not bad once you learn it. So we're going to spend a bit of time at the beginning just going through what everything means, what's actually happening in a normal distribution. So it's not the exam questions that are scary. I think they often look really crazy. But what it is the understanding is often not there of what is actually happening behind the scenes. When you know that, when you understand that, trust me, the questions are going to be so much easier. So I will spend a bit of time just talking about that, but hang tight, it's going to make sense. And then when we approach the questions, you'll see it's not so bad. All right, so when we are answering exam questions, you should always sketch the curve. And it doesn't have to be fancy. You don't even have to have like this X line here. I mean, sketch the curve like that. It's always going to follow a bell curve. You can immediately put in your mean there. Your standard deviations are going to be a certain amount. So if we have something that's a standard deviation away, that's a negative standard deviation away from the curve. As simple as that, it really helps you to figure out what you have to answer in the question. So here are two bell curves. Now, can you see that they have the same variance, right? So they've got the same shape of being away, but different means. So the mean of this one is here at 0, and the mean of this one is here at 3. But they have the same spread. This distance and this distance are the same. Same spread. Spread, just another word for deviation. Here we have the same means. You can see they're both on this line. They're both 0, but different variances. So, or different standard deviations. Let's just talk about standard deviations for now. So this one, we have the mean being there, and that's the distance between the standard deviations. If I take a curve that's like really tall like that and a bit thin, and the mean is like that, you can see the standard deviation is quite small. So that means the data is more close to the mean. It's not so spread out. Here it's quite spread out. And if we do it like this one here, it's like really, really spread out. All right. So always sketch it. Promise you it's going to help. Now, when we're finding probabilities that are less than a certain value, remember the probabilities are just the area under the curve. So the probability that x is less than a, let's give it a number because sometimes that helps. Probability that x is less than, let's say 5 centimeters, x is less than 5 centimeters, is all of this area here. So when you're putting that into your calculator, what it's actually giving you is this probability, which is this area under the curve. Okay. Remember, all of them add up to 1. So we're going to be doing questions like that. If If you have greater than probabilities, this is the important part. This is where things get interesting. Your calculator is giving you values that are less than, okay? So if you ask for a value at A, your calculator is going to give you everything less than. So if you want this bit, the bit that's more than, to find that, you need to find this and then subtract it from 1. So 1 minus this area under the curve. And that's going to give you the missing place. So when you have this plus this, it gives you 1. So if we want to find this, we say 1 minus this, because your calculator will always give you values to the left of A. Very important. That's why drawing a diagram is really important for these questions. Similarly, between probabilities, this is if we have two values. So we want between here, A, and here, B. I want to know, what is this area? And luckily, most calculators are going to give that to you really nice and easily. You'll put in your A value, you'll put in your B value, you'll put in your standard deviation and your mean, and it will just give you the area immediately. Some calculators, however, are not able to do that. So what you would have to do is you'd have to break this up. You'd have to first find this area, right? Then you would have to find the whole area from this point and then subtract them to find this place here. And here we have a little formula for that. So you find the area from B all the way down, that's the red, that's that, and subtract it from the smaller green area over here. And that's going to give you this. I want that. All right, so I mentioned the empirical rule earlier. This is something that you have to memorize. Let me just check anything in the chat. No, I'll try and check and answer if you have anything. All right, the empirical rule. You need to memorize these values. So if you are taking notes, which I hope you are, write down 68%, 95%, and 99.7%. Very random values. These are the three important percentages you need to know about. And questions, they're going to ask you about these values, but they're not complicated. They look complicated to start with, but they're not. Just make sure you memorize them. So what does this mean? They say that for any normal distribution, 68% of the data lies within one standard deviation. So let me draw this for you because that often helps. So here we have the mean in the middle. Okay, there's our mean. Now, if we add one standard deviation away, that's there. So that was plus 1 standard deviation. And to the left, that's minus 1 standard deviation. That's theta, 1 standard deviation. So that's there. That is minus 1 standard deviation and plus 1 standard deviation. So let's just shade that. Let's go with that. So that all over there is going to be our 68% of the data is located there. So that doesn't include that and doesn't include that. That makes sense, right? 68% of the data is there. Now, if we take 2 standard deviations away, let's go, that's another one, minus 2 standard deviations. And here, plus 2 standard deviations. That is, let's now shade that in red, going to be all of this, right? Now that is 95% of the data is located there. And finally, 99.7% of the data is going to be 3 standard deviations, see all the way to the ends there. So if we mark that, that's minus 3. It's going to be all of this. There is still a missing 0.3 over there and over there, split between the two. So it's almost everything, which makes sense. 99.7, that's very close to 100% all of this, adding up to 1. But there's going to be a little bit missing there and a little bit missing there. So I'll show you an example of how this is going to look, but we'll have some questions that say, what percentage of the data lies between this point and this point? And you will have to recognize that it is maybe 2 standard deviations away from the mean, just by calculating. And then you can say, because it's 2 standard deviations from the mean, we know that that is 95% of the data is located there. All right, that's looking like a mess. Let's just take that away. All right. Any questions about that? I can imagine that it might look a bit strange and weird, but it will make sense. All right, so we have first example. Sorry, that was a lot of theory and information, but hopefully now we put it into practice and it starts becoming clearer. The time taken by students to complete a test follows a normal distribution with a mean of 45 minutes and a standard deviation of 8 minutes. Write down the distribution of t, the time taken. So that just means write down what the distribution looks like. So we have a variable x. If they don't tell us otherwise, we just say x with the little squiggle. It's distributed normally and for normally. And we had, I'll write up here so you can see, we had mean and then standard deviation and squared. So mean is 45, standard deviation is 8, right? And we write squared. So we actually write it like a variance. This is just the typical way that it's shown. So that could be 64. If it is written like that, if it is written as like 45 and 64, just make sure that you don't take 64 to be the standard deviation. That is the variance. If there is a squared there, you know that that value is the standard deviation. So just an important note. And they'll most often give it to you like this with the little squared. All right, use the empirical rule to estimate the percentage of students who take between 29 and 61 minutes. So the empirical rule, let's write our percentages. They were 68%. Oh, I asked that in the chat. What were they? Anyone answer? Everything's clear. Good. We had 68, we had 95%, and we had 99.7. Once you've worked with these a few times and done a few questions with them, you actually might be surprised how quickly you'll just remember them. But don't forget to check them one last time before your exam. All right, so if we're having a look at our diagram, let's draw it because like I said, it helps so much if you draw it and see what's happening. Our mean is at 45, right? One standard deviation, that's going to be plus 8 because our standard deviation is 8. Over here, it's going to be minus 8. So 45 plus 8, let's write that. That would be the mean plus 1 standard deviation and the mean minus 1 standard deviation. So 45 plus 8, we're going to have 53. And 45 minus 8, we're going to have 37. All right, let's have a look. Those values, nope, they don't match up. 53 and 37, not the same. Okay, let's try take 2 standard deviations. So let's take away another 8 and add another 8. 2 standard deviation. I keep doing theta. Okay, so 53 plus 8. Well, yeah, that gives us 61. Look at that. And 37 minus 8. I'm just taking away 1 because I already took away 1. But you could also say taking your mean plus 2 times 8. So taking away 16. So 37 minus 8. Yeah, that's 29. Great. That's exactly what we wanted. And that was 2 standard deviations. 2 standard deviations was this one right here. So using the empirical rule, we estimate that the percentage of students that take between this and this time, so between 2 standard deviations of the mean, that's all of this area here, that is going to be 95%. And that's an example of how the empirical rule will be used. So very, very important when you see, they might not say use the empirical rule, they might just say estimate the percentage. And that you need to think estimated percentages. The only time I estimate percentages in normal distribution is these three guys over here. So there we have it. That was the answer. 95% of the data of students take between 29 and 61 minutes. So on our scale here, at our 2 standard deviations, we'd have 61 and 29. Now, estimate the percentage of students who take more than 61 minutes. Okay, that is more than 61. That was 2 standard deviations. This part here, that little part, the rest. So what percentage is lying there? Well, if 95% is happening in this green area, that means, I'm going to put another area here that we haven't calculated, before 29. Remember, it's symmetrical about the mean. So this area here is the same as this area here. So if 95% is in the middle, that leaves 5% for the remaining 2 parts. So each side is going to get 2.5% of the data. 2.5 and 2.5%. So all in all, double check, does that add up to 100%? Yeah, it does. So that means that the percentage of students who take more than 61 minutes, just that part, more than 61, is 2.5%. So hopefully that helps it to make a bit more sense. Right, let's do another example. I think we're going to use our calculators now. The volume of juice in a carton is normally distributed. So V, the volume normally distributed with a mean of 330. I like to write it out just so it's really clear to me. 330 and a standard deviation of 5. See the little squared there? So standard deviation is 5. Find the probability that a randomly chosen carton contains less than 325 mils. So let's write that as a probability. P of X is less than 325. And it doesn't matter if you write that underneath or not in continuous, because remember, we're taking every value. So it makes no difference. There's no right or wrong answer there. You can write either. In discrete, it does make a difference, but here it doesn't. Okay, so that's great. We are going to take this straight to our calculator. I have this one. If you have a different one, it's going to be quite similar, the steps that we take, and hopefully you know where to find your probability distributions. If not, I have a little ChatGPT slide that I can show. And let me know if you need to see that, but I'll show you for mine. So we want menu. We want to go to probability distributions. We could also go to statistics distributions. Both they're exactly the same thing. And we want normal CDF. In our exams, we're not going to use normal PDF. It's always going to be CDF. In discrete, in binomial, we use PDF and CDF, but not in normal. So we want normal CDF. Make sure that's what you click. All right, so our lower bound, X is less than 325. That means we're taking everything from 325 underneath the curve. We don't know what that value is, and that doesn't matter. So we just need to pick an extremely large negative number. Okay, so we're going to use minus 9, E999. That's just the calculator notation. That means minus 9 times 10 to the power of 9999, which is giving us an extremely large number. And your calculator takes this as a large enough number to mean like negative infinity, basically, because it doesn't do negative infinity. Our upper bound was at 325. Then our mean was 330. And our standard deviation was 5. 5. There we go. All right, so we get normal CDF from a very large negative number to our value that we're interested in with our mean and our standard deviation 0.1586. We want 3 significant figures, so that will be 0.159. So we write 0.159. Very important in these questions, because most of it is happening on the calculator, that you need to set it up properly. You need to write this notation. Don't just write this. You will get a mark for having this as well. And then I had something else that I was going to say, but I've forgotten. Maybe it'll come back to me. So make sure, oh yes, so you don't need to write anything like I use my GDC or I press these and these buttons. This is enough. You never need to say that. They will just assume you are using your calculator for this, because there isn't another way. Not that we know of, at least in DP. Everything all good? All right. So the heights of sunflowers in a garden are normally distributed. H, height, distributed normally with 180 mean and 12 standard deviation. Find the probability that a randomly chosen sunflower is taller than 195 centimeters. So could you write the probability inequality we're looking for in the chat? What are we looking for? We want the probability that X is taller than 195. What they said. That's fair. Yeah, nice. So taller, we want probability that X is more than 195. Okay. So again, draw a little thing with our mean over there, and we want more than 195. So if our mean was at 180, 195, not exact, but somewhere around here, 195. So we want to know for this area over here, more than 195. All right, and remember, our calculator actually only gives us what's to the left. So what we're going to do is we're going to work out this area. We're going to work out less than 195, and we're going to subtract it from 1 to give us this value. Very important. This is why drawing is important, because it's not going to give us this value. We need what's to the left and then subtract it from 1. So I'm going to rewrite this as, instead, the probability, or 1 minus the probability that X is less than 195, the opposite. So I'm finding everything less than and subtracting it from 1 to get that green area. So let's have a look at what that would be. So I can already, even on my calculator, type 1 minus, and then it's just going to insert it like this for me. So menu, probability, or stats, distributions. We want normal, CDF, again, very low value, and upper bound 195. We have 180 and 12. Okay, there we go. So it's done for us. That's 1 minus. If we're doing it like this as well, it saves us on maybe inaccurately rounding. Be very careful when you're rounding on these questions. For each question, you need to round to 3 significant figures. But if you're doing a question B that is using an answer from question A, don't take the 3 significant figures answer. Take the full answer, and then every answer ends with 3 significant figures. But that's just an IB thing. So we want to take the full value to get the most accurate answer. All right, and we get 0.106. Right, let's just double check. Yep, that 5 needs to go up to a 6, and that's 3 significant figures. Okay, so the probability that a randomly chosen sunflower is taller than 195 centimeters is 0.106, or we can say 10.6%. Okay. Well, lots of examples, lots to get through. So here we want to find that the temperature on a chosen day is between 25 and 32. That's lovely. We want between 25 and 32. No funny business here. We're just going to set that as our lower bound, that is our upper bound, and the rest we can copy in. It's great when they ask us these kind of questions. So lower bound would now be 25. Upper bound would now be 32. I ignored my own rule of drawing the bell curve, but for now, I'm just going to skip through that. You shouldn't on your exam. but because I want to get to some later questions and inverse normal, but always draw it. Sorry, our mean was 28 and 3 for our standard deviation. So there we go, 0.750. And keep that 3 significant figures always, even though it's a 0. Very important. Okay, hopefully you're still doing good and not overloaded with information. Hopefully things are still making sense. If there's anything you're not sure about, feel free to put it in the chat. And I can also go back to it. At the end, I'll do a question and answering. So if I missed anything in the chat, I'll go and have a look and answer that. But in the meantime, I hope everything's clear. Take a look. Lovely, by the way, for the answers. Okay, so are we ready? Inverse normal. Now, this is doing the reverse. So previously, we have been given an x value, and we put that all in to find the probability, the area under the curve. Now we're doing the opposite, the inverse. We're going to get given the area under the curve, the probability, and we have to work backwards, or our calculator will work backwards to find the value of x. So what this might look like is, previously I had said, okay, there's a value that was like 195. What is the area under the curve? Now I'm going to say the area under the curve is 0.67. I can't help it. What is the value of k? All right, so working backwards. That's all it is. And it has a function called inverse norm, inverse norm. So that's the reverse. The only thing that might be difficult about this is the way that the question asks it. So here's a few key things to look out for. Things like in the top 10 or the highest 10. That means in the top 10%. Okay, and remember that you are, when you're finding the top 10%, that's say here, this is the top 10%, that would be 90. Well, that's not 90, but the area under the curve is 90. So top 10%, that's 0.1. So everything to this side is the 0.9 or 90%. So your calculator is going to return this. So you'll have to find this, the 0.9, which will give you that value. So it's going to be the opposite. If it's something like the bottom 5 or lowest 5, it's also like the bottom 5%. That is a nice one because that would be something like that. That's the bottom 5%, 0.05. A lot of students I see in exams write 0.5. Be very careful, 5%, 0.05. So your calculator will return that value immediately. So you'll say inverse norm where the area is 0.05 for bottom 5%, and it will give you that value because it's to the left. Right, so if we want to the right, remember we need to work out what's missing there. 90% of the values are below a certain value. So if we draw that, 90%, that's around here. So that's 90% are below. Again, that's to the left. That's all fine. You can find k. Slightly more difficult question would be something like it's in the middle something percent. So you're going to need to find two values here, middle 80%. So let's take the middle 80%. So middle 80% means that I'm going to have 10% on this side and 10% on this side to all add up to 100%. So there's going to be a value here of k, my k1, and a value here of k, k2. So to find my k1 value, that's actually fine. That's not a problem. I can find that easily because it's all to the left, right? So if I type in that my area is 0.1 on inverse norm, I can come back and find my k1. For this one, however, if I want this value, I want to know this. So everything to the left is actually going to be 80% plus 10%. So that will be 90%. So if I want this value, I want to know everything to that side, which is in total 90%. So these are just a couple of ways the question might ask. So again, diagram helps. Let's see what that looks like in an actual example. The time taken by students to complete a puzzle is normally distributed. Students in the slowest 15% must repeat the puzzle. Find the minimum time that results in repeating. So slowest 15%. So if we think about these, where we're looking for, slowest 15%. Are we looking in the top 15% or the bottom 15% of students? Think carefully about this one. So if they give us the curve, would they also give us the area? Yes, they will give you the area. So that will always be a hint. For example, here, 15%, that's the area under the curve. So your probabilities, I want you to think probability is area under the curve. So if you have that one, then if they've given a probability, then you know the area. I hope that answers your question. All right, so this one is a bit tricky, and this comes up quite often actually, that the slowest 15%. Now, if you're thinking about time taken to complete a test, time taken, right? If you're slowest, you're taking more time. So the slowest 15% of students are actually going to be in the top 15%. Something about the word slow makes you think bottom 15%, but it will be in the top 15% of students. So this area here is the slow people. They've taken more time to complete the puzzle, right? So that's always a funny one. So that would be 0.15 is over there. So that's the area under the curve for the slowest. So again, we are going to be finding to the left of the curve. So to the left of the curve, we're left with 0.85. So that's the value we're interested in to find this value of k. So let's find that. Okay, we need the function inverse norm or inv norm because we've been given an area, the probability, and we need to work backwards to find k. So let's go to our calculator. So we had 12 and 2.5. Let's see if I can manage to hold something in my head for more than 5 seconds. Distributions, inverse normal. Most will say INV normal or just inverse norm, but inverse normal. Okay, the area we had 0.85. The mean, I've forgotten, 12 and 2.5. Okay, so that was given, that we figured out, and there we go. 14.59, so 14.6 to 3 significant figures. So this value of k over here is 14.6, 14.6 minutes. You can just write inverse norm. We had 0.85 for the area, how that looks, 12 and 2.5 was equal to 14.6 minutes. IB loves the unit of measurement. It was minutes, right? The time taken. No, they don't actually say in this question, but I'm assuming minutes and not hours. So the minimum time that results in repeating is 14.6 minutes. Okay, so what I want you to remember, if it was slowest, if there's anything like that with slowest, anything to do with time, think about it a little bit more in the context of the question. All right, now we get to one of those fun ones where it's a range, right? Where we need to find the 2k values. So any guesses what I'm going to say now? Draw it. Not sure what made sense, but I'm glad. That's great. So we want to find the range of diameters. So on the x-axis, we have the diameters. We want to find the middle 90%. So let's draw in our 90%. Really, the accuracy here does not matter. Everyone thinks they always need to have a perfect drawing, but you don't. So that's 0.9. Now, let's think about it. On this side and on this side, what is left in 0.9? Well, we have 10% left. So on this side, it's going to be 0.05, 0.05. So that's that area, 0.05, 0.05, and in the middle, we have 0.9. So what they're asking us for is this value here. No, that's not what I wanted. Okay, I want this value, that's my K1, to find the range, and this value here, K2. Okay, my K1 value, that was really nice and easy because it's to the left of the curve. So I can just find inverse norm for 0.05. Inverse norm 0.05, nothing crazy here, 10 and 0.03. Okay, let's go ahead and do that. A little shortcut is instead of going all the way through the menu, you can just select the previous one, go enter, and then change the values. That can sometimes save some time. 10 and 0.03, just make sure you do them in the right order and have a memory retention better than mine. 0.05, 10, and 0.03. Perfect. So for that one, we have 9.95. So my K1, 9.95. Drawing these diagrams can also help give you method marks for showing understanding, but it is recommended that you try and show these things. K2 is now, okay, so remember from here, we want to find this value. So it's not just 0.9, it's all the way back. So all the way there is what we want to know up to this value. So that's 0.9 plus, sorry, that got cut out, 0.05. So we want to know inverse norm for, stood down there, 0.95. 0.05 plus 0.9 all the way. 10 and 0.03, these don't change. Oh, I read that. So again, I'm just going to go back, and especially for this one, don't have to change much. 10.04, so 10.0. You might think, why am I writing 10.0? Why don't I just write 10? Well, we need 3 significant figures when we're rounding. If I just write 10, that makes it seem like the answer was just 10. If I write 10.0, it shows that I rounded, and it wasn't exactly 10. I mean, it's very close, but I do need to show that I rounded and give 3 significant figures at all times. Aren't you guys excited to not hear the words 3 significant figures in a month's time? So, any questions? Are they always going to give the mean and standard deviation? That is a good question. They are not always going to, but we'll look at how we're going to find that next, hopefully. Yes, right here. Great question. So in most of the questions before, they would give that to do the inverse norm, to do area under the curve. Sometimes they will not give you the mean, or they don't give you the standard deviation. So we're going to use something called the standard normal distribution. So I'm also aware that we have maybe about 12 minutes left. So I'm thinking that we might do a past exam paper specific session possibly on normal distribution questions, because I know that they do look scary, but they're all just asking this and what we're doing. So if you can understand everything so far, then you should be good for normal distribution. Just the first instinct, I think, is to really freak out when you see the questions, because all of the inequalities, all of the squiggles, everything that's going on. But just take a moment, take a deep breath, and try and really piece out what they're asking you. And once you've done a couple of practice questions, you'll see that it's all quite similar. Okay, so if they don't give you the mean or the standard deviation, you're going to use something called standard normal distribution. So standard normal distribution is taking something called the Z-score. Remember, we saw this formula at the beginning. And the Z-score and standardizing is a way of making the data more consistent. So you can take any normal distribution and apply we say standardizing it, give it a Z-score, and that means we can compare it. They are going to be on the same scale. It's just a nice way of being able to compare data. You don't need to know too much about that. What you do need to know is the formula for it. And your key is if they do not give you a mean or they do not give you a standard deviation, that means you need to standardize it, okay? So anytime it's not given, standardize. Use the formula in some way. So I have the formula here. This is in the formula booklet. This is the same formula over here, but can you see it's just in terms of x, not in terms of z. Same thing, doesn't matter. We can take this one, z equals x minus, see it's using the mean and the standard deviation, and we can rearrange it. So z times our standard deviation equals x minus mu, and then we want it in terms of x. So let's add mu to the other side. So 7 is not 7, reading my own handwriting wrong. Z standard deviation plus mean equals x. And that's the same one that we have over here. It's the same thing. All right, so we're going to be given certain values and we're going to need to use inverse norm. So just important to remember about a standard normal distribution is it looks like this. Every single one. This is the standard one. X is distributed normally with a mean of 0 and a standard deviation of 1. This is universal standard. All right, and you're going to get a z-score that takes your x score, converts it to a z-score, which will always have this mean and standard deviation. Time-wise, I'm not going to explain that too much, but if you wanted to know a bit more about it, it's not super necessary for DP, but if you were curious, ChatGPT is your best friend or a maths tutor. Okay, so let's see what we're given. We're given that the probability of x is less than 80. Okay, that's our x score. X equals 80. The area under the curve is 0.9. Okay, area under the curve, 0.9. And our standard deviation is 12. So let's see, what are we missing? Well, we have x, great. We don't have the mean. They haven't given us the mean, okay? So that's going to be something we're going to have to figure out. Z, we don't know our z score, okay? That's where this is going to come in useful. And our standard deviation is 12. So that we have. So 2 unknowns. This is our end goals, finding mu. So to find z, what we're going to do is we're going to use the inverse norm with the probability, with our standard normal distribution to find our value of z. Now, these have all been pre-calculated. There's a huge table of values where this is all worked out for the standard normal distribution. Anyways, it doesn't matter. Make sure that even though we know that the standard deviation for the x is 12, when we're finding out z value, we're going to be using 0 and 1. Super important to remember that. Do not use 12 here because we're standardizing it. So let's go and inverse norm that. So menu, probability, distributions, and inverse norm. Now our area was given 0.9. And see, they've actually already, the standard is that they're here already, 0 and 1. That's what your calculator always comes up with, or at least this one. So that's all there. We don't need anything. So our inverse norm is 1.28. Sorry, our z value was in norm. Probability was 0.9 and 0.1. And they gotten it already, 1.28. Okay, now we have our z value. Great, we have everything that we need to find our missing value here. We have x, we have z score, we have standard deviation, we can find mean. So let's write out that formula. You could use this one as well. And anyway, I'm going to rearrange this one to give me in terms of the mean. So I'm going to subtract x minus z mu. That gives me my mean. Okay, so x was 80 minus z score was 1.28. When we're calculating, we don't want to round too early. Time, which was 12, standard deviation. And that gave us our average, our mean. So let's put that into a calculator. 80 minus, and I'm going to take that value again. Whoa, look at that. See, we don't want to round too early. Times 12. So times 12. No brackets necessary here because of BODMAS or BEDMAS or BIDMAS. What's the American one? It starts with an F. No, parentheses, PEDMAS, whichever one you use. All right, we get 64.6. So our average, our mu is 64.6. And there we go. We were not given the mean, but we used a normal variable formula to find the mean by finding, and then we could calculate the mean. So think about what variables you have been given from this formula, and then see which ones do I need to calculate. So if you're given, sometimes you'll be given the mean and you have to find the standard deviation. It works exactly the same. Another way that you might get asked is you might not be given the mean and the standard deviation. But think about when you have systems of simultaneous equations. You have like, I don't know, 2x plus 4y equals 10. And you want to figure out x and y. Well, we can't do that with just that. So we needed to have two equations. We needed a second set of values to be able to find out x and to be able to find out y. So it will be the same thing here. If they don't give you the mean and the standard deviation, they'll have to give you two normal distributions, two sets of data that you can put together in the very same way as this. You're still going to set up, that will be your first equation with your first information. You'll set up another one just like that, and you'll solve it like a simultaneous equation by elimination, substitution, whichever. Because these are just some nice linear equations. All right, I'm aware of the time, so let's see. Yeah, I see there's a few questions. So I think what I'm going to do is stop there. I think most of the things have been covered. Again, this is just a question using this, and we had some exam style questions that we might need another session for. But now you have all of the information that you need to be able to do normal distribution, and hopefully it's making a lot more sense. Let me see what questions I can answer. Let's just scroll down. Just a couple of exam tips. Like I said, probably 20 times, roughly sketch the curve to understand the situation. Make sure that you don't confuse standard deviation and variance, and don't round too soon. I think those would be my top tips for normal distribution. If anything here was unclear, or if you wanted to practice more or go through something or just have notes, Exam Dojo has amazing notes on every single topic. So you go to Learn here. I mean, there's assessments, question bank, all of that, but Learn, amazing notes. And there's examples with answers. So you look for, that was binomial distribution, but their normal distribution. And then plenty of notes, really, really well explained. There's a homework assignment. The class codes will be on the info page, which I will send with the link now before I forget. So there you have the link with all of the information and the next sessions coming up. All right, let's go to questions. So would you lose marks if you write 10.04? I think that was for when we had 10.0. No. So you see here, they give often, this is an example of a mark scheme. Here, they give the A1 mark for having those three significant figures. That is when it's usually, they've usually given method marks before for having something. So if your final answer is meant to be the final answer, that's three significant figures, and it's not, then you don't get the mark. But if you have all of the working before, and then you round, and you don't round three significant figures, that's fine. My top advice would be anytime you have a question, let's say, I don't know, x equals 0.5234. 6, to write the full thing, just in case there's a mark for that, because sometimes they give it, sometimes they don't. So instead of having to remember all the rules for when they do and when they don't, just write the full thing and then round to 3 significant figures. And to be really fancy, you should use approximately, but you don't have to. 5, 2, 3. Then, yes, so in the TI-84, they have left, center, and right. Now, it's been a long time since I've used that calculator, and I do remember something about that, but I can't remember exactly when they use left, center, and right. What I am thinking that means is when they had this, left was calculating that part of it, right was calculating that tail, and center would be calculating that. So if one of you have that calculator, could you type it in, and then let's see, let's do center. So let me give you a question. Let's say the probability for a normal distribution, X is distributed normally with, just say 0 and 1 for now. And then we want the probability that X is between, say, -5 and 10. All right, and if you're doing this one, click center. I think what I remember is that you have to tell the calculator where it needs to calculate it from. So see if you can answer this question and find the center. I'll do the same, and then I can show you what the answer would be, and we can compare. So we wanted normal CDF. Was that a normal CDF or was that an inverse norm? Also, what I can recommend is when you're not sure about how to calculate things on the calculator, to ask ChatGPT. So say when the calculator gives me left, center, and right, what is that meaning? It's actually really good at giving like the full list of things. So I apologize that I can't answer that better. It's been a long time since I used a TI-84. I used to know about that, but moved on to the TI-Nspire. Then how do you know when to use 0 or 1 in the inverse norm? So, sorry. Excuse me. So when you use the 0 and 1, let me just go back to that, is when you're not given a mean or a standard deviation. So that's when you need to use it. So mean and standard deviation, one of them or both of them are unknown. That is when you use the inverse norm of 0 and 1, because we're standardizing. Or if they use the word standardized or standard, anything like that means that we're using this distribution with 0 and 1. So standardizing when mean and standard deviation are unknown, or find the z-score. These are all clues. So z-score, always going to have 0 and 1. All right. Will there be more sessions in the future? Yes, there will. So we have 2 sessions tomorrow. The information is given on that link. And we will be organizing quite a few more sessions on different topics. So in the survey, statistics and probability were the ones that people wanted to see the most. So that's why we started with them. And after that, I think we'll be doing some calculus, and can't remember which one was next, but we will send out the topics soon. But yeah, there will definitely be more sessions. Then, for example, for mean, you put 0 or 1 and then standard deviation the same. So sorry, what I mean is that in this, the mean is 0 and the standard deviation is always 1. always. So if we have a look at that on a bell curve, let me just get rid of that and draw a curve. So in my standardized normal distribution, I'm going to have my mean there, and it's going to be 0. That will always be the case for a standard normal distribution. And then my standard deviation will be 1 away and -1 away, or 2 and -2, or 3 and -3. So that's for 3 standard deviations away, but always it's centered at the 0 for the mean. Yeah, standard deviation is always 1, mean is always 0. Every single time, doesn't change. This is like, you know, when we have parent functions like y equals x squared, and that is like the one. Well, this is the one of standard normal distribution. So it helps us to, it's kind of like giving normal distribution the same language. So we all speak different languages, but if we want to compare those languages or all understand each other, we're all going to use the standard normal distribution because it's going to have the same parameters, i.e. 0 and 1 for mean and standard deviation. And it's going to help us to be able to compare different sets of data. It makes it consistent. Just like a school uniform is a standardized way of making people dress. This is our standardized way of making normal distributions comparable. The 4 sessions, they don't cover all topics. I've just picked the ones that are usually the ones that people have the most trouble with. So I think things like scatter plots and whether they're weak, moderate, strong, linear, nonlinear, etc. Those are kind of the more easier to grasp topics. So the ones that people struggle with the most or that occur the most in exams. So there will always be normal distribution or binomial distribution or both. So I really want to make sure that we cover that. And I think a lot of students struggle with them. I mean, you could write in the chat right now if there's topics that you really, really want to see coming up next. So the next one that we have tomorrow is on Pearson's correlation coefficient and regression lines and y on x. So reading those and x on y. That will be the morning one. Then the afternoon one, the later one, is going to be on conditional probability and various probabilities, which students often struggle with. Yeah, kinematics, that's a big one. I know that will definitely be on there. Kinematics, optimization, things like that. Is what's in IB? Sorry, could you be more specific on that? Can't remember what I was saying. Are you referring to is kinematics in IB? Yes, it is. It's just an extension of differentiation, calculus. So taking what you've learned in calculus and applying it to real life situations. But again, one of those ones sounds scary, but when you go through it and know if there's always all these tricks, as soon as you know the tricks of what they're asking in the exam questions, things become a lot clearer. Yeah, no worries. There's a lot going on. All right, trigonometric functions, that's another one. I think I have answered the questions. In my next session, let's say tomorrow's one, in the morning one, I will start by going answering that question of the left, the middle, left, center, and right, unless someone has an answer, because I really can't remember what it was. Like I remember using it, but I can't remember. So sorry about that, but I will put the answer for that in the next session. You're very welcome. I hope that it was useful. I hope that you learned something new. Even if you had a good understanding, hopefully there was something you didn't know. I know it's a lot, but well done for coming on this Saturday evening or whatever time zone you're in. Right, for the areas under the curves. But for the areas under the curves, is it when you're doing inverse normal or just calculating the probabilities? That was the question. I can't remember. All right. Yeah, don't forget the homework is on the task. So if you haven't yet joined the class for the homework for each session, the codes are on the document on the link I've just sent. It looks like this: Exam Prep Bootcamp M26. So whichever course you're doing, there's a class for you. It's called Homework Session 2, Normal Distribution. And yeah, you can use the class codes there. All right. Then have a lovely rest of your evening or morning. I don't know where people are joining from. Thank you for staying. Thank you for listening. And I'll see you at the next session. There we go. End live. Goodbye.